Okay, I'm going to do this one by pattern, but I will talk about the work that I've written down for you. There's a variety of ways of doing things. Don't think one way is the only way to do something. And I'm going to write this down as a pattern problem. And certainly, this is what Wells would have done too. He wouldn't have been dividing or seeing any other patterns except the ones he's expecting to see. And let me write this down as m plus n. And then let me just get rid of the ruler. I don't know what happened there. I touched it, I guess. Let's talk about the descending powers of m. All right, so it's going to be m, 8, alternating, m7, and then it's going to be n, 1 power of n. Alternating, m6, n squared. Alternating, m5, n cubed. Again, I want to point out, alternates, the sum of the exponents is always going to be 8. All right, let's do the next one. Plus m4, n4. Let's keep going. I'm running out of room. Minus m cubed n5 plus m squared n6 minus m n7 plus n8. Very nice pattern. All right, now someone says, I don't see that written down. Let's talk about what they did. And someone says, why is there variance on this? Well, the bottom line is you could look at this thing and say, well, maybe I can continue factor, but this is certainly one pattern for the factorization of it. Yeah, it may not be the best one, but it is a factorization of it. So I'm not going to say it's complete factorization, just it's a factorization of the problem. So let me point this out to you, and I want to make sure you understand what I'm saying over here. Oh, boy, I got to get my thing back. Where did it go? Oh, I'm sorry, it's over here. I'll put this over here. So, you know, really simple pattern. Let me just go through that. M8, M7, M6, M5, M4, M3, M2, M1, no M's. Then I'll go backwards on it. N8, N7, N6, N5, N4, N3, N2, N1, and then no N's. Alternating pattern. Minus, plus, minus, plus, minus, plus, minus, plus. All right? That's not so bad if you did that, and that would be a good answer. Certainly, I think most teachers would look at it and say, good job, all right? So what I want to talk about, you know, maybe some other student would do it a little differently. And I want to point out, you know, doing it differently, you know, what I noticed if I did it differently, I might want to write down that this is really m cubed, cubed, right? 3 times 3 is 9, right? Plus, I'm sorry, I got to go backwards on that. That's n cubed, cubed. All right, so maybe someone, so at that one, then they saw the sum of perfect cubes. And what would they get? M cubed plus n cubed. That's not so bad, right? And then what do you get over here? Well, if you looked at that, you'd probably, you know, you have to square that, right? So it's m6 minus m cubed n cubed. Well, that's not so bad. And then what do you get? Well, you would get plus n6. Now, if a student did that, I'd say, good job. All right, let me point out where this is in the notes, by the way. It's right over here. All right. All right, I'm looking at that, and then someone says, geez, could the student go further than that? Well, what I notice over here is that I could, and I'll tell you why. I'm seeing this thing, and that's a sum of perfect cubes. That's m plus n times m squared minus mn plus n squared times m6 minus m cubed, n cubed, plus N6. This is also a fine answer. I want to point out it's also listed over here. And where's that answer over there? Right here. Right of answers. I think what Wells is looking for is the first one I put down, though. Just a pattern recognition. But you know, you say that there's some creativity of way you could see that, all right? Now, I got to be honest with you. If I were looking at it, I probably would say this one is my preferred answer, all right? Now, granted, this is Wells's preferred answer. Your mileage, again, may vary, all right? Thank you.